one other piece there is just, I guess, like, where is there the most meat on the bone to improve Solana? So like, if you drew out a diagram of like the whole, from a user wallet to the blockchain, there's like this whole rigmarole that a transaction has to go through. So in that whole Solana process, like, where do you find that there's the most room for improvement?
I would say just the performance and the speed right now. I mean, we are still doing 1,000 transactions a second, right? So there's Tolly, I think, has this like sliding scale of pain that he talks about, which is that like user pain is the most important. If a user feels any pain, that's like really, really bad. If a developer feels pain, it's kind of bad. It's not ideal. We really want developers too. And then if a validator operator feels pain, that's not terrible. Like we should fix it. And then if a core protocol developer feels pain, who cares? And if maybe like Tolly feels pain, like people enjoy
Yeah.
that. But so the user pain is the worst, right? And there's a bunch of other problems we can go solving, like operator problems around how to run a validator better, or developer problems like around SDKs and tooling and writing, secure programs. But like the user pain is the most important. And the user pain is like kind of two things. It's like I sent a transaction and it didn't land quickly, and I sent a transaction and got dropped. Like there wasn't enough capacity on the network. So I think there is a lot of excitement here, because it's not like we need to go and do a crazy more amount of deep work. Like the CU increases are coming, and they're coming very rapidly. There has been a bunch of low-hanging fruit. I think Alessandro from Anza likes to say that it's all just bugs. People think these performance problems are like, that they're like foundational engineering challenges, and we need to go re-architect this and build data centers and route dam water into that. And it's like, no, like the software mostly has bugs, and you can fix them and realize like pretty significant performance wins. And yeah, maybe when we get to like 200, 300,000 TPS, we'll have to go do crazy, re-architecting and re-engineering of some of the clients. But no, right now we can get huge wins by just clearing out that debris and taking the easy ones that are there.
But I'm saying, like, on a micro level, like, where are the easy wins? Like, where's a lot of the debris? Is it like the fee markets? Is it the way that transactions get propagated throughout the network? Where have you found that there's a lot of improvement that can happen?
Oh, interesting question. Well, so in Frankendancer, we can already probably do a few 100,000 TPS if the compute unit limit was raised. I mean, we've run, we run private clusters that can do far beyond that. So Frankendancer, I think, was an exercise in figuring out a lot of where that debris was. For the most part, it's in the leader pipeline. So you need to be able to pack blocks that are that big, right? If the compute unit limit was 300 million, and we need to be doing 10,000 transactions a second. There is a little bit of involved work in, okay, like we need to receive all these transactions well, we need to rank them, we need to put them in the block, we need to execute them quickly. So we took a design there that was largely inspired by Agave, but had a bunch of kind of key changes, and that enabled us, I think, to do really, really well there. So the Agave team is kind of like taking a fresh look at their leader pipeline for the last year. I mean, they've made some really, really good improvements. And so, the scheduler is probably the biggest component of this. If you think about the work a validator has to do when it's leader, it has to do some work that you might think is hard, like verify transactions, right? You have to check that the signature is valid, that the user that's transferring the funds is authorized to do so. This is like a cryptographic operation that's pretty expensive, but it's like scalable, it's parallelizable, so we can run it on many CPU cores of the system. So no matter how many transactions we're receiving, we can just scale up capacity to process it. On the other hand, the problem of scheduling, like deciding what goes into a block, basically has to be done on a single CPU core. Like absent some incredibly novel, like groundbreaking engineering, you pretty much have a list of transactions, and they may conflict with each other, right? They're trying to send funds from the same account, for example. So you need a single place that has a view of all of this and like really, really quickly schedules those transactions for execution without trying to send funds from the same account twice. That, I think, was a big bottleneck in Agave. We have a really specialized custom scheduler for Firedancer that'll be also used in Firedancer that we've put a lot of engineering effort into solving this like single core like performance issue. And it's basically a greedy scheduler, right? It runs through transactions highest value to lowest and just tries to schedule them each in turn. And it turns out if you try and do too much complicated work in there, like figure out what transactions are dependent on which and like do some smart analysis of who can, then you end up just stalling your scheduling. So Agave and Anza realized this also probably a year or two ago, and they've done a lot of engineering work to change their scheduler also to be a greedy scheduler. So that's kind of like some of the work that's, it's not like build data centers and write computer science papers and it's just like, okay, our scheduler is slow. Let's write a new one that, is using a much simpler algorithm.
Isn't Alpenglow going to be, it's doing, it makes changes along these lines as well, or am I misremembering?
Not quite. Alpenglow maybe has one nice benefit. It's currently the case that votes on Solana, so when a validators vote on whether a block was valid, are transactions, then they get sent to the leader, and the leader has to put the votes in the block. Alpenglow changes this so that the votes are kind of distributed out of band through a separate system. So in that sense, it maybe is a minor improvement, but
the scheduler thing is a separate consideration.
Yeah.
Gotcha. I want to talk a little bit about modding. There's this kind of, I don't know, environment in Solana where I think one of the difficulties is just things that happen out of protocol that are hard to always observe. So including like modding your validator to have some desired effect. So I'm curious how Firedancer handles that.
Yeah. So we support it. I think, there's like probably two futures with modding, and one of them is good and one of them is bad, right? Like a bad future with modding is that one team writes a big mod that kind of says, oh, we're going to be the team that receives all the order flow and decides how to create blocks, and we're going to win and no one else will be able to compete. And then everybody just runs like one mod. And that's probably not great for Solana long term. There is another future which is much more likely, and probably what will happen here, which is like there's a vibrant ecosystem of mods, and everybody has their mods that they've written and they share, and some people like run this and some people run that, and there's different agreements in the space around what transactions get sent where, and it's like kind of a thriving little ecosystem. I mean, I guess there's a third future where like nobody runs any mods at all, but I don't think that's an eventuality. So we're pretty excited about like this second one where, there's a ton of mods and it's easy for people to write and try new things. I mean, that's how you get, evolution, and like how you let like good ideas surface. And then maybe if they're really good, we bring them into the protocol. So in that sense, I think we're long-term supportive of modding. One of the like initial mods, we wanted to support was Jito. Our goal is to be neutral, right? So we want to support anyone that wants to build anything on top of Firedancer. We want to support them. We want to have standard tools and processes for them. Jito is a cool initial case because they have a lot of adoption in Solana. So we thought, when we were supporting this Jito integration, is like, how do we do this in a way that's really clean? So what we want is for them to kind of be able to run in a little sandbox, right? They can build this block engine integration where essentially we can uphold two properties of the validator that are really important to us, right? Which is the performance. We're still able to do 1 million TPS theoretically, and security, where like there's not a big attack vector or something because of one of these mods. And so we use that as kind of an initial case to say, okay, how do we support this system effectively? And what we found is like with the underlying architecture of Firedancer, It's actually very straightforward. All of Firedancer is built on these kind of primitives we use in the trading space, which are kind of message buses, right? Messages get passed between different parts of the system. And so when you're going to write a mod, you can just subscribe to any messages that are going internally between the system. You can send messages, which are transactions. So we found that we're actually able to have a pretty flexible modding infrastructure. And I think in around a year or two, we're going to actually publicize some of it and write a bunch of documentation and have a really, really nicely formally supported way for people to have mods.